In Module 2, Lesson 16, we're going to continue our work with the standard algorithm for addition, and this time we are going to regroup twice during each problem. In the last lesson, we regrouped once, and I showed you how to do that both with the standard algorithm, and I also showed you how you do it if you had manipulators in front of you, showing you how to use the flats, or flats, longs, and cubes, which are those yellow things that we choose in class. So where a long has 10 cubes in it, the cubes are obviously represented one each, and a flat has 100 cubes shown in it. So I'm going to show you a problem with that as well, and we'll spend most of our time working through the standard algorithm. So with that said, let's get started. All right. So we are going to have a problem like, I don't know, 360, my pen's being really slow, 7 plus 400, nope, not 400. I like to have the bigger number should be on top. 200 and, oh, my pen's giving me all kinds of trouble today. 294. Okay. So what does that look like? Let's take a minute and get it drawn out. All right. Let's hope this pen starts cooperating a little bit more. I have ones place, my tens place, and my hundreds place. I said this last lesson, but we won't have to draw this out every time, but it is a good tool to show you and really give you a good understanding about what's going on. So for the first problem, I certainly will. Over here, I'm going to show on the top, I have 3 flats, each of these being 100. I have 6 longs, each of those being 10. 2, 3, 4, 5, 6, and 7 ones, or 7 cubes. 1, 2, 3, 4, 5, 6, 7. And I'm adding that to 2 of the flats, again, each of those being 100. I have 9 longs, 4, 5, 6, 7, 8, 9, and 4 cubes, 4 ones. So I'm adding these together. Okay, so what do we do? Well, we start over here. Again, we can only have 1 digit in each of these places. Like we cannot go and put 2 digits in any one column in our answer, in any of the place values. So 7 plus 4, let's do that first. 7 plus 4 is 11. And because 11 is a 2-digit number, I can't just put, I can't put 11 there. That's not possible. I can only have 1 digit. So I have to go and make a 10. So I have 7, 8, 9, 10. If I take 3 of these from the bottom and combine them with 7 from the top, I end up with a 10, right? I'm going to take that and I'm going to move it over there and add a long. And then I'm going to get rid of them. So I moved them all so they're no longer in the ones place, they're now in the tens place. And I have 1 remaining cube there, which turns out to be a 1 in the ones place. Well, now I move over to the tens place and take a look here. And again, I can only have a 1-digit answer here in my spot. So I have 9 plus 6 is obviously more at that point than 10. So 9, and I'll take 1 of these to make a 10. Pen is giving me all kinds of trouble. Let's try this one more time. There we go, we kind of got it. So that's 10 tens. 10 tens we know is 100, so we're going to trade those in for a flat. And again, we've moved them, so we'll X them out here. Okay. So what do we have left? We have 5 plus 1. We have 6 longs or 6 tens. And then we can go over and take a look at our hundreds spot. We have 3 plus 2 is 5, plus 1 more is 6. So we have 6 hundreds. All right, that delay is really making it hard to write. Let's go ahead over here in our standard algorithm and see if we get the same answer. 7 plus 4 is 11. That's a 2-digit number, so I can only put the 1 from the ones place here, and the 1 from the tens place I carry over here into the tens column. I then add 9 plus 6 plus 1. I'm going to combine this 9 and that 1 to make a 10, and then I have 6 left over. So I end up with 16. I can put my 6 there and carry my 1. So again, this is like, since it's in the 10 columns, it's really 160. So I'm leaving the 6 tens for the 60, and I'm carrying 100. So again, we have 100, 6 tens, and 0 ones, which is 160. And then I have 3 plus 2 in the hundreds column, which is 5 hundreds. And then I have 1 additional 100 that is carried over here, making me have 6 hundreds. My answer is 661, just like it was on the right-hand side here. So I hope that picture model helps you. I showed a couple of those examples in the last lesson. I'll show one more in the next sample problem coming up, and then we'll do a couple without it. So here we go. We'll have, let's see, 264 plus 88. Okay, so here we have a 2-digit number and a 3-digit number. I'll separate these out into the place value columns for you, just to give you a good picture of what's happening. Ones, tens, hundreds. And we'll draw it out on the right-hand side as well. And I know we're taking our time here. And for some of you, you'll say, Mr. Burnell, I already know how to do this. I don't need you to show me. But it's good practice. It's good to understand why things work the way they do. So it's one thing to understand how to go through a process and get an answer. It's another thing to understand why that process works. So that's why we're taking our time here. So with that top number, we have 200. So we're going to have 2 flats. Again, those each are composed of 100 cubes or 10 longs. 6 longs are showing 6 tens. So 1, 2, 3, 4, 5, 6, and then 4 ones. 1, 2, 3, 4. And we're adding that to no flats because we have no hundreds over here. We have 8 longs, 4, 5, 6, 7, 8, and 8 cubes for 8 ones. Okay, now we can start our addition. And I'll start on the right here. We'll work back over to the left in a moment. So I have 8 plus 4 in my ones column. I'll even separate these out into columns for you here. I have 8 plus 4, which is 12, which is a 2-digit number. I can't put a 2-digit number here in this column. I can only put a 1-digit answer there. So I'm going to combine these and make a 10. So I have 8 down on the bottom. I'm going to take 2 from the top. And I'm going to trade those in for 1 long because it's one group of 10 that I just made. What is remaining right here? I have 2 cubes, which can go down to the bottom. And my 12 is represented here because I have 1 10 and I have 2 1s. So 1 10 and 2 1s is 12. Let's go on to the next part here. I have 8 plus 6 plus 1. Well, that's going to be a situation where we're going to have more than a 1-digit solution. So 8 plus 6 in itself is already over 10. That's 14. So let's take the 8 and combine it with 2 of these, right? And that gives us a group of 10. We can take that group of 10 and trade it in for a flat and then see what's remaining. We have that 1 up top with the 4 remaining. That gives us 5. Okay, so again, we took 10 longs, combined them together, traded them in, and we got a flat out of it. Now over here on this side, we have 3 flats, which is 300s. So we ended up with an answer of 352. Let's see if the same thing happens when we go over and work with a standard algorithm. I have 4 plus 8, which is 12. So I put a 2 in the ones column and a 1 in the tens column. Again, 1 plus 2 is 12. Or I'm sorry, 10 plus 2 is 12. Then I go and I say 8 plus 6 is 14, plus 1 more is 15. Or better said, 80 plus 60 plus 10 is 150, because we're working in the tens column here. I can't write 150 in here, so I have to just write the 5, the 50, and I take the 100 and I move it 100 over here into the hundreds column. So this shows 100, 50, and we had 0 additional ones there because we've already dealt with our ones. Now I have 100 plus 200s is 300s, and I end up with an answer of 352, just like I had here on the right. So that shows how we can regroup twice to get a solution to an addition problem using a standard algorithm. And I showed you that picture model again, which is how you'd use manipulatives to demonstrate this process. Let's do a couple more, and this time without the pictures. Hopefully you're developing a good understanding of that. So we might have a number. Let's do a tricky one here. 705 plus no, I can't do that. Let's see. 6, 6, 2. There we go. That should work. So 705 plus 626. I have 5 plus 6 is 11. That's in my ones place. So I can't put 11 down here by itself. I can only put 1 for the ones place. The 10 for my answer gets carried over, regrouped over to the 10 spot. Then I have 20 plus 10. I have plus 0 is 30. So I put a 3 in the tens column. So I regrouped once so far. I carried once. And now I'm going to go over here and do 700 plus 600. Well, that's more than can fit. I can't fit 1300s in the 100 spot. So I really am going to put 300s, and I created 1,000 too. So I know I don't have 1,000s place over here, but really what's happening is I'm putting 1,000 up there and adding it to 0,000. So both of these answers, and I end up with an answer of 1,331. Let's go through one more problem, then I'll let you go and work independently on your homework today. We're going to do the problem 555 plus 497. Okay. 5 plus 7 is 12. So the 2 goes there, and the 10 goes into the 10. 110 goes into the tens place. Now I have 9 tens plus 5 tens plus 1 10. That's going to be 15 tens. Too much to fit in my space here. Again, I only have room for 1 digit in each of these spots. So I have to say my 5 goes here from the 15, and my 1 goes here. Now I have 500s plus 400s is 900, plus 1 more 100 is 1,000. I'm actually going to regroup 3 times in this problem. That's why it took me so long when I was originally writing it out. I had to think through that for a minute. So I have 1,000. What I'm showing here has 1,000, and it has 0 hundreds. My pen stopped working. There we go. These 2 I'm not worried about because we already dealt with them in this problem. So I have 0 hundreds right there, and I have 1,000. Again, that's being added to 0,000 in both of those spots. So 1 plus 0 is 1, and my answer becomes 1,052. And that is how you carry when you're using a standard algorithm to do addition. Ask questions if you have them, please.